My notes say that last time we did ACT, we got through question 42. So, start with 43.
Sorry. Okay.
Just hold on. All right.
Sorry, quick question. Do you have scratch rooms on the ACT?
I'm not sure. I'm sure that they either give you scratch room or let you bring paper and pencil.
All right.
Yeah. Are you taking the SAT or?
Sorry, ACT.
I know. They just announced the other day that they're changing the rules on the SAT.
Oh, really?
Yeah, they're changing the way that they take. There's no essay anymore,
Okay.
and they don't let you use your calculator on parts,
Oh, excellent.
which is a big change. Both tests have let you use your calculator for a long time. So, but I'm not sure when that change is going into effect. It might not be until 2016. What's that?
So I graduate.
Yeah, I know. You may miss it. You may end up being affected by the new one. I'm just not sure. But regardless, they're not changing the ACT. So, okay, number 43.
All right.
We have a triangle.
Okay.
30-60, and angle A is that, B is that, C is the right angle, and AB is 16. What is the area of the triangle?
All right. Is this a trig problem or is it?
No, it isn't. It's a knowing your 30-60-90 right triangle. You know my unit triangle that I'm always putting up there? What I call my unit triangle? What are the dimensions of a typical, my unit triangle? Opposite. Go ahead. What is it? No. Opposite the 30 is 1. What's opposite the 60?
2? No?
The 2 is the hypotenuse. In other words, you want to remember that with those dimensions down here, because this question is a similar triangle problem. That's all it is. In other words, they're saying, okay, we have a 30-60 triangle that has a hypotenuse of 18. In order to get the area of this triangle, we need its base and its height. So what are those two dimensions? It's the scale factor. Or the similarity. Yes, it's 8. In other words, every side needs to be 8 times as big on this triangle, the bigger one, as this little triangle here.
So you have 8 times 2?
What's this side over here? 8. What's this side, CA?
Cube root of 8, or no, what would it be?
8 root 3.
Okay.
In other words, 8 times this is 8 root 3. Now the area is 1/2 base times height. What do we have?
You have 1/2
square root of 3.
Oh, sorry.
It's all right.
Sorry.
And that's 32 root 3 is the answer.
Awesome. Okay.
So you always want to be able to do these similar triangles.
Is there anything, like, is there a similar base square or something like that, or is it just triangle?
The two they want you to know are the 30-60 and the 45-45. These will pop up a lot on the test. And if you memorize everything you see below that line, oh man, that's funny. I tried to move it over and I reduced, now I can't. I've never had this happen before. I'm trying, I can't grab the title to move the thing. How do I do it? That's odd. Let's see. Well, I guess I can always do this. Open it and... No, I can't. Move. Hold on a second. This is very bizarre. I've never had this happen. Move, I guess. There. You see what happened? And then now I can, oh, there we go. Oh, that was so strange.
Yeah, very.
Okay. Number 44. Which of the following line goes through 0.3 and is perpendicular to the line y equals 2x plus 1?
Okay, so
what's the slope of the perpendicular line going to be?
it's going to be 3 because
The slope of this line is what?
it's going to be 1/2. So
It's the negative reciprocal.
oh, sorry.
So the slope of the perpendicular is negative 1/2. That makes it easy. What's the answer?
G or F. Sorry.
Yeah, and notice we didn't even have to use this information. Obviously what that information is the y-intercept. The fact that it goes through 0,3. That's the y-intercept. So that 3 makes sense. But as long as they're only going to put one answer on here with a negative 1/2 slope, we don't even need that part of it.
All right.
45.
For this one, can you just plug in random numbers?
Yes, you can. That's very good. I like that idea. Well, I love that idea. I just did this problem earlier today, and I did it completely algebraically. But I like your suggestion better, actually. So give me some random numbers for width and height.
So 2 times as long as it is wide. So the width could be 1, if you want to keep it low, and then the length could be 2. And then the length is tripled, so that would be 8, would it be? Or 6?
3 times.
Alright, so not 3, I mean, like, okay, never mind, so 3 times. And then, so that would mean that the width would be 2.
Area of this one?
2.
Area of this one? How much bigger? What's the ratio? The area of the second rectangle is how many times as large as the area of the first?
6 times?
Uh-huh.
Or,
Very good, yes.
yeah?
Yeah. Mm-hmm.
Could you have just multiplied the triples and doubles to get that answer, or do you have to actually solve it out?
I think you have to solve it out. Yeah, I don't think that works. The way I did it earlier is I let x be this side, I let 2x be that side. If this side's 3 times bigger, it has to be 6x and 2x. So this area is 2x squared, and this area is 12x squared. Divide the 2, and you get 6 to 1. Okay, let me open a different page here. Okay. They do start getting a little tougher, as I noticed earlier today. So what would the value of z have to be for there to be an infinite number of solutions to those 2 equations?
Okay, that's a question. Would it have to make it equal to 108?
Not quite, but you're on the right path. Let's talk about systems of equations. How many solutions does this single equation have? X minus y equal 10.
2 solutions, 1 for x and 1 for y? Or
Well,
does it not have 1? 10.
I could be 12 and 2. I could be 13 and 3. I could be 14 and 4. I could have an infinite number of solutions.
All right.
In other words, how many different XY pairs could you get? Well, there's no limit. So when you have one equation and 2 variables, you have an infinite number of solutions. If I have 2 equations, if they're different, now I can solve for a single solution. I can add these 2 equations and come up with x has to be 15, and if x is 15, y has to be 5. So I have a unique solution because I have 2 different equations and 2 variables. What if I give a second equation like that? Now how many solutions are there to those 2 equations?
1 or infinite many, because when you...
Exactly. In other words, I didn't really give you any additional information with the second equation. I just gave you the same equation multiplied by 2. Well, I can't solve this. If I try to solve this using elimination, I get 0 equals 0. I get no solution at all. So there are an infinite solution to this. Well, that's what this question is saying. They're saying here is one equation, 24x minus 15y equals 108. And here's a second equation. What do you notice so far about the 2 equations?
Triples?
Exactly.
Yeah.
So far, every term is triple that. So, if I were to triple that, that would be exactly the same equation as that, and I would have an infinite number of solutions. Make this number anything other than 324, and I have a unique solution. I don't have an infinite number of solutions. But if this is precisely 3 times this, then I have their requirement. And they're saying 9z has to be that number, 324. So what value of z would make that second equation exactly the same as the first equation?
So then you'd have to divide it by number.
Divide 324 by 9.
And then
What do you get?
0, okay. Oh. 36.
And that's the answer. In other words, if z is 36, then this second equation becomes 72x minus 45y equals 324, and it's an exact multiple of 3 of the first equation, which means you would have an infinite number of solutions.
Okay. That's cool.
Yeah, different for sure. All right. How many prime numbers are there between 36 and 54? There's no magical way to do it other than just to go through every number between those two and see whether it's prime or not. 30. Okay.
38 is not.
You don't need to check any even numbers. No even numbers above 2 are ever prime because they're always divisible by 2. So that makes the task a little easier. We can just check odd numbers. 39?
No. Isn't the rule that if you add them together and they're divisible by 3, it's divisible by...
Yes. That's a good, yes, that's very good to remember. 3 plus 9 is 12. 12 is divisible by 3. 39 is divisible by 3.
Okay.
41?
No. Yes. It is.
43.
Yes.
We also don't need to check any numbers that end in 5. So 47.
Yes, I believe.
49.
Wait. No. Yes, it is.
7 squared.
Yeah, okay.
That's all right. 51.
No. 3.
Nothing divides into that except 51 and 1. 53.
No, because you can, wait, no, yeah?
Yeah. In other words, what makes a number prime is if you can't find a factor for it, then it's probably prime.
Yeah.
Now, it's a little tricky knowing, in other words, for 49, you have to recognize that that's 7 times 7. but 51 and 53 don't have any, those aren't the answers to any multiplication table. So you have 1, 2, 3, 4, 5, 6. 6 prime numbers between those two. All right, here is probably as hard a trig problem as you'll see. I shouldn't have said anything because it's not that hard.
Okay. Okay. Tangent A. So tangent is opposite over adjacent.
Okay.
So the opposite, that side is X. The side across from, and Y. And then the sign is the opposite over Y over X.
Sine is what?
The sign is the opposite over the adjacent?
Hypotenuse.
Okay, sorry.
So is opposite over hypotenuse. Ka is adjacent over hypotenuse. Toa is opposite over adjacent. In other words, this was X and this was Y because Toa is opposite over adjacent. So what's the hypotenuse here?
X squared plus Y squared is going to equal the hypotenuse squared?
Yes.
Square root of X squared plus Y squared.
Very good. Now what is the sine of A?
So X over the square root of X squared plus Y squared?
Good.
Why can't you just make that X plus... Never mind. No, I know.
Yes, that is not X plus Y quantity squared.
Right.
Okay, so Aisha is going to create a circle graph to show how she spends her 24-hour day. And she is going to draw a sector for playing the piano that is going to be 1.5 hours. What should that angle be?
Alright, well, it's 360 in the center, right?
Right?
And then you have... should you take the percent that 1.5 is out of 24?
Yeah, it's a ratio problem. 1.5 is to 24 as what is to 360?
Yeah.
Solve for x, and you've got that angle.
Would it work if you divided 1.5 by 24 and then multiplied it by 3?
Yeah, you could do that. It goes in there. No, it doesn't go in an even number of times, does it?
No, for the calculator, okay, here's my question though, because that's how I did it.
Mm-hmm.
And the answer I got is one of the answers on the paper.
22.5?
Yes.
That's it.
Okay, I just didn't know if this was one of their trick answers for when you do it wrong, but the answer's in.
What exactly did you do on your calculator?
So I just took 1.5 by 24, and then I multiplied that by 360.
Yeah, that's the same thing as multiplying both sides by 360. You get x equals 360 times this ratio. So that's exactly the way I would have done it. Or you could divide 360 by 24 first. If you're going to do it manually, it's a little easier to do that because that's a nice whole number. And then multiply that by 1.5. But Since they still letting you use calculator on this one, you don't need all those little tricks.
Would you say that the SAT, the math, is there a math portion of the SAT? Yeah.
Is there a what question?
Is there a math portion?
Yes, there is. Now, I would say, well, first of all, there's no trig and there's no conic sections on the SAT. So that would appear to make it simpler, but it doesn't really, because the average math problem on the SAT is more difficult than the average math problem on the ACT. It's just that the ACT covers trig and conic sections and the SAT does not. So maybe overall they're about the same. I would say the ACT are easier because the trig covered is very, very basic trig. It's not, you know, it's trig you can learn in a half an hour.
Okay.
All right. Let's finish up on this problem here. A, B, and C lie on the same line. They don't tell us what order they lie in, but they're on that line. AB is 9, BC is 11, AC could be what?
Is it... What's the difference between the answers J and K?
Very good notice. None, which means neither one of them can be right.
Okay.
Because they're the same.
Wording.
Well, all I've done is switch it. This or this, and this one says this or this. So they're the same answer, and then you never see two answers the same, so that can't possibly be it. So we only have 3 to choose from. It's either 20, or it's 2, or it's 2 and 20.
Okay.
Clearly, in my upper diagram, 20 is a possible answer.
Yeah.
About the lower diagram, I know that AB is 9, and BC is 11, AC is still 20. So changing it to that doesn't do anything. Put A in the middle and it changes things up. Now, AB is 9, BC is 11. That would make AC 2.
So the answer would be H?
Yes.
Oh.
Yeah. Now, if you're taking this test, the giant leap you have to make is these points are not in a row. They're not A, B, and C. They lie on the same line, but they didn't say they were in that order. And if you don't make that leap, the only picture you can come up with is the top one. So you'd be inclined to say 20 only. But know that this problem couldn't be that easy. Okay. Wouldn't be much of a problem if the answer was 20 only. So you can kind of figure out that there must be something else going on here that I'm not drawing in my model. What could it be? The points don't have to be A, B, C. They could be CBA or CAB or any combination. They just all lie on the same line. And the moment you make that realization, you come up with the right answer at some point. There's still a little bit of work to come up with H as the right answer, but you can do it. Okay, let's end it on 50. And let's see, we are meeting Wednesday at 3:30?
Yeah, sounds great.
Okay. Talk to you then.
Excellent. Thank you.
All right, Sarah. Bye-bye.